Hi, everyone. Very good morning to you all. I'd like to start by saying how very excited I am to be here today. This marks quite the difference from my last year's talk at HashiCorp Europe, where I had the privilege of presenting to a smartphone on a tripod in the comfort of my one-bedroom flat in London. So today, what I'll be using our time together is I will be talking about terraforming our tenant and how we've delivered a solution to self-service apps as code. So to kick things off, I'd like to ask everyone in the audience a question. By show of hands, who of you have previously thought to yourselves, if I could start fresh on designing my system, I'd be using an infrastructure as code approach? OK, there we go, a couple of hands. Great. So the good news is I'm not alone, not crazy. But more importantly, unfortunately, we have to face reality. Like in many other types of development, we simply don't have the luxury of starting fresh whenever we want to, especially if our systems are already depended on by a number of users or stakeholders. So my goal today here is to answer the following question. How do I migrate to using infrastructure as code whilst maintaining the user experience? Well, again, in short, with great difficulty. But don't worry, we've got another about 28 minutes for us to go through everything I wish I knew from the beginning and everything that I've learned throughout that journey. So today, my talk will be in three parts. I'll begin by introducing our Azure Active Directory tenant. I'll tell you where we started and why we felt ready to begin. Next, I'll go through what we've actually built, the principles, and what we've done to deliver Terraform for this purpose. And of course, it wouldn't be fair to you if I didn't level the playing field and do a reality check. I'll tell you what it really cost for us to do this, as well as what we've gotten out of it. So, quick round of introductions. My name is Peter Barta, and thankfully, as of yesterday, I've got good news, and I'm now a senior cloud security engineer at Norges Bank Investment Management. Thank you. Thank you. Very chuffed as well. I've been designing and building security solutions within the IAM space for a number of years now, and I'm a huge fan of self-service and automating things away. As for NBIM, also known as the Oil Fund, we are Norway's sovereign wealth fund, and the largest in the world at that. Valued at over a whopping $1.2 trillion US, we have a critical mission of ensuring that we safeguard and build financial wealth for the future generations of the Norwegian people. Now, if you've ever heard the expression, a finger in every pie, well, I think NBIM is probably one of the best examples of that, with certain ethical exceptions, of course. We are invested in over 9,000 companies worldwide and own 1.4% of all publicly listed companies. So next time you think about pretty much any company, you can think future prosperity of the Norwegian people. So why is it that I think that we're a good use case to learn from? Well, with just over 500 employees spread across Oslo, London, New York, and Singapore, we're both a diverse but incredibly lean organization compared to the size of the fund. And as I'm sure many of you know, when in such environments, you have to build for incredibly efficient solutions that are easy to use and scale with the business. Next, we support the fund with a combination of internally developed and industry-leading tools, and we do this in a fully cloud environment. So like many of you, we're looking to use the latest and greatest and ensure we're at the forefront. And of course, we do all this to enable the optionality and pace of development needed to remain a world-class fund. But it's clear, those very same qualities and attributes help you succeed within your own respective industries as well. So let's talk our tenant. Where did we start, and why did we start? So the focus of today is on our Azure Active Directory tenant. It acts as our primary identity provider and services us in three key areas. The first of those is that it houses all of our application and service identity definitions. Now, we're not the biggest tenant by any means, but we still have well over 600 applications already defined and that need management. Next, it also houses the authentication configuration for all of these applications, and many of these apps have additionally complex configuration setup to enable single sign-on, or whatever else we might need for the time being. And, of course, a significant portion of the authorization is also controlled through our tenant. We have thousands of app roles and assignments to users or groups to ensure that we have the right permissions and privileges in place for all of our applications. Now, as our tenant has continued to grow over time, we've noticed that we've increasingly felt the friction of not abiding by our own principles. So let's take a quick look at what those are. Firstly, of course, like many of us here in the audience, we strive to deliver everything as code. It's an industry best practice and reduces manual, hands-on work that we want to move away from under any circumstances possible. Next, we have to ensure that we have a strict and efficient change control process. We need to be able to protect our production services across the fund at any time. And lastly, we have to ensure that we're following security best practices. We need to be doing and following least privilege at all times. That's always clear. Then, when we took a hard look at where we really were, we realized that we weren't quite hitting the benchmark on all of those points. The reality is that for all of those 600 applications, from onboarding through to managing the entire life cycle of that application, we were doing it manually and hands-on through the user interface. Not great. As part of that, we had some applications that were managed by their owners and others that were managed on behalf of the owners by teams more experienced. So we had a very inconsistent change control process where some users were involved and others weren't. Not great again. And what these 2 points were actually symptomatic of is that we had a wider security problem. We had a huge number of application developers and over 10 tenant-wide application admins to actually support doing all of this work manually and hands-on. So, not really following least privilege there either. Now, I mentioned at the beginning of the presentation that there is, we don't all have the luxury of starting fresh. We would like to think we can, but, well, business says no. So, what actually happens when you look at this brownfield problem? We had to decide when the right time for us to begin was, and with that, we started at our maturity review. So, like the cycle begins, we take a look at ourselves and say, we're not quite at the benchmark that we need to be at. We say, well, that's right. Infrastructure as code would be the best practice. It would make us industry leading, and we should be doing it. So let's go for it. Great. So we're now in the midst of it. We begin our market research and see what's out there. In our case, we began looking at the Terraform provider. Now, what inevitably happens is we don't quite hit all of the use cases that we need to cater to already. Our environment has a number of demanding applications, and we should be able to manage all of them through Terraform. But if we can't, we have to wait. So we say we're not ready, and we should wait for the provider to release more features, mature some more, and be ready for when we do need it. Of course, the next step is that we scrap the project. We said we're not ready yet, it's not there, it's not mature enough, let's wait. And of course, what we've done is we've come back full circle, and this cycle will repeat over and over and over again until we eventually decide that something has to change. Now, spoiler alert, something does change. I'm here talking to you today, so that's good news. But what was it? For us, it was the introduction of an engineering threshold. We had to critically evaluate how much work we felt comfortable investing to reach the success criteria and the value that we needed to achieve to make this project successful. So, thankfully, we actually found that we were ready. We felt like we had the engineering talent, we had the time, and the need was great enough for actually to embark on this project. So here we go. We get started. Now, the biggest point of pain typically comes right when you begin the project, and you've got this sort of golden mist over your face, and you're thinking, we're ready to go. But then you have to wake up and face some very hard truths. It's not that easy to build the solution that you need that's going to be perfect. So we looked at the first phase, and for that, that was going to be the design and implementation. For us, we realized that because we were building to support existing applications, we were going to have to build for the past. And that meant recognizing that, well, it's actually It's quite literally impossible for us to build an application today the way it was built 3 years ago. So there were some very real limitations that we had to overcome with what the provider could do for us. Next, we looked at the operating model and how people were going to use this. We're moving away from a user interface, and to ask that challenge of end users is not a small thing. People like their UIs, and they're very accustomed to them, so you have to give them a dang good incentive to actually go down this route. The same applies to the admins. When you take away admins' perms, they're not happy. So how do you actually appease them? And of course, when it comes time to using it for real, we have to think about what it means to migrate. We have a huge number of applications that are already there. We have to import them. That in itself is a challenge. But even more so, we have to make sure that we do it gradually. When you work in a lean environment, it's not enough to do a big bang change. So how do we do this gradually? Well, I've just given you a lot of information and a lot of challenges, so I'll take a quick check. Hands up if you're still with me. Wonderful. Most hands. Good. So let's talk about Terraform and what we've actually built. So we started with our design principles, of which there were 4. For each one of these design principles, I'll go through and explain what we did. First of all, we had to be human-friendly. It had to be easy to use and intuitive for users to get started. They had to follow patterns that they were already familiar with. As I mentioned, moving away from a UI is no small change. Next, we had to give back control to our users. It's not enough for them to be able to do some things themselves, but others they have to be reliant on another team to do for them. This notion of control needs to be back in the hands of the owner of the application. Next, we have to fail safely. It's not good enough to say, sorry, it broke, when an application owner tries to do something themselves. They have to feel confident and empowered to do things their own, knowing that they won't break everything at the same time. And lastly, the change has to be easy. It has to be an easy migration to make sure that we get the highest rate of adoption and the most people that are actually satisfied and happy to use our solution. So, each one of these in turn, what did we do? On the note of human friendliness, we had to design for familiarity. I think the first thing that comes up on this slide is something that's quite eye-catching because I think it's almost the exact opposite of human friendly. So the first thing that we did is we said no to IDs. Now, I'm sure I'm going to anger some developers and some hardcore advocates of this whilst I do this, but we had to say, if you want people to use a codified approach and take them away from a user interface, you had to find something in the middle. And for us, that was to make everything human readable. We did the same when it came to the configuration language. If you're expecting users to change, you can't just say, oh, do you mind learning this new proprietary configuration language for me? You know what they'll tell you to do. Yeah. So we opted to use YAML. It's already well established within our business, and our developers are very familiar with it. So that meant we could do it a lot more easily. And I think you'll all agree with me, what you see on the left is a bit of a pain compared to see what you on the right. What I think it's like is if you had a friend or any number of colleagues, and you tried to remember their name using their phone number instead of their real name. It's not great. It's not going to work. Next, I mentioned the user interface. In Azure, you would normally click through a number of different panels to configure different elements of the application. So how did this translate to code? Well, what we did is we took an approach where we had to map what they were already familiar with into a simple and intuitive file structure. We started with a base.yaml, which contained the very core elements of an application that needed to make it work. So we then progressively added more and more files to cover all of the remaining areas. Not too many, of course, just 5. But more importantly, we made sure that everything was optional. You only needed a base.yaml to get started. And when you were comfortable and you wanted more configuration, you knew where to look and you knew how to find it. Nice and simple. On the point of ownership, I mentioned that there are things that people are dependent on for the IAM team to do on their behalf, but we need to make sure that they can do all of it themselves. Otherwise, they'll never become independent. So we opted for a GitOps workflow. We made it self-serviceable so that anybody could write into the repository And we used tools that were available to us within GitHub, like code owners, so that people could define who would be responsible for an application. This way, we had a much better change control process as well, because team members and owners of applications had to approve every change. They were involved, and they owned the process. On the point of failing safely, we had to ensure that there was going to be minimum risk of destroying or breaking our production systems that people were already dependent on. So we did this in a combination of ways. We started with our Terraform-based controls. So those of you familiar with Terraform, you understand the idea of a state file. What we did is we separated each of our state files out for each application. We isolated them. Now, some of you would definitely, and rightfully so, complain about what that means. But I would like to remind you or encourage you to think, if anybody here has done state file surgery previously, you'll understand just how painful that is. And I would liken it to doing CPR. It's great that you can do it, but you really hope you never have to. And as part of building a custom module, what we did is we were able to ensure that certain configuration elements were always going to be set to what we wanted them to be. People couldn't make changes that might potentially put us at risk, and we could enforce certain security controls this way. And of course, I did mention GitOps. So we have options here for us to actually add additional checks the way we do in GitHub pull requests normally. So we had linting and validation on every pull request, ensuring that people were referencing correctly created applications, the right group names, the right usernames. Make it safe. We added, like on a bowling alley, you've got those nice little rails to help you play safely. And what we found is that we were actually improving our disaster recovery posture as well as part of this. We've codified all of our apps, and every time a change is made, we know exactly what it was that was going to break an application and how to get it back to a working state. So it came time to actually use our solution. How did we do that? I mentioned that we had to import all of our existing applications, and that can be a challenge. So we had to find a reusable way of doing this, reusable and repeatable, of course, to ensure that whenever people were ready, they could begin using our solution. The answer for us in this was to create a reusable process that meant they could generate the code definition as well as import their application on a regular basis, so that when they were making changes one day to the next, that would still be repeatably up to date within the repository, so that when they were ready to switch over, they would have the latest definition of their configuration in code already for them. Of course, this also applies to making sure that when we use new applications, people can have templates readily available for them to use super easily. Because everything is a code, copy and paste, change a couple of fields, it's much more friendly than actually going into a UI and trying to configure dozens of different fields and click through 15 different pages. So all in all, what does this workflow actually look like from the end user's perspective? So if we look at an existing application, what happens in the first two steps is essentially invisible to them. We generate a codified definition for them, as well as import the application. And we can do this repeatedly, as I've mentioned. We have separate state files for every application, so we simply recreate it whenever we need to. And whenever the user is ready, they submit their very first pull request. As for creating a new application, copy a template. You have an app that you know that works, just copy the existing app. Simple as. You make a few changes, and again, you're back to the very first pull request. And the only time we need IAM approval for any of this is at that first pull request, where you define the code owners and the people that are going to be responsible for managing that application from that point forwards. Now, I have mentioned that we've actually covered a lot of different problems. So in the first instance, I said we had to build and extend Terraform. So how did we do that? Well, quite literally, we extended Terraform. We added additional scripts and data sources, and we ran additional things that used the API alongside Terraform. As long as Terraform wasn't upset, we weren't upset as well. But it gave us the same control we needed ultimately. For our operating model, we solved a lot of the issues that we had by ensuring that we used an easy-to-own and familiar structure for users. They were accustomed to what they had seen, and we did this very gradually. And on the note of migration, a safe and easy migration was part of it, but something that I've failed to highlight is actually doing it incredibly gradually. We had a very long pilot period, 6 months in fact. Maybe that's not too long, depending on who you ask, but for us it was quite long. During this process, we invested in spending time with each of the teams, as well as technical and non-technical representatives across the business to see how they felt using this solution. We had very short feedback cycles and made sure that when we got feedback, we listened to them. This, in turn, transformed them. They were now supportive. They were champions for the solution, and they understood the benefit that it gave both to them, the business, and our security posture as a whole. So, it's time for a reality check. I've talked you through a lot of different bits and bobs and different implementation options, but we all understand at the end of the day, you have to build something, and well, you're going to have to crack some eggs. So, for us, what cost did this come at? The first is that there are some very real consequences of our design choices. I'll be the first to admit, Terraform has some very, very cool features, such as the dependency mapping between plans and understanding what order to execute things in. That's great, it is. And we have ultimately basically removed that because applications are now completely separate. So we have to have ordered changes. But what we found is, thankfully, we don't have a great deal of application changes that are completely dependent on each other. So we can stomach that for the time being. Next, there are some very real limitations of the tools and strategies that we've used today. And we've added a lot of complexity because of the fact that we've had to engineer additional elements to what we've built. So we make API calls, for example, and we're now dependent on managing whenever the Azure API changes. If any of you have worked with the Graph API before, you'll know how often, how frequently, and how unreliable it can be at times. There are a lot of breaking changes, and we have to be ready for those. The same applies for our module. We have to be aware of whenever our provider changes and ensure that we cast our version and limit it where we are and make sure we vet every possible change. And of course, I wouldn't be here today if it was all that easy to do. There are actual engineering challenges here. It took a lot of time to build, and testing and repeatedly trying all of this, it's been quite cumbersome. So there are certainly costs to be aware of, but I don't think that it's fair to say that it's all negative bits and bobs. Rather, we've actually got some positives as well. So what were the tangible things that we got out of this? Well, I mentioned at the beginning, there's an incredibly high overhead for managing 600 applications manually. You can only imagine the number of support tickets that we were getting every week for changes of all sorts. Could you rotate a credential, update a login URL? Users simply didn't feel empowered to own their own applications. And as such, they were requesting us to do it on their behalf. So what we've actually delivered is a halving in the number of support tickets that we're getting every week. That means that we have so much more time to build these sorts of solutions and ensure that we're actually delivering values in more sustainable, long-term ways. Next, because we've built all of this, what we've actually built are foundations as well. So this code isn't going anywhere, and it most certainly is reusable and repurposable. We built pipelines to deploy Terraform, manage state files, and all sorts of other things. This isn't going to change overnight, and we can continue to reuse it and make the most of it when the next project comes around, and we go through that cycle of deciding what the next thing is that we're going to migrate to infrastructure as code. So we'll be ready and prepared when that time comes. And of course, like we set out to accomplish in the first place, we needed to make sure that that security and velocity gain was very real. We've matured our security maturity, and actually, we're moving much more quickly. When there's a user that wants an application, copy and paste something, submit a pull request, and they're ready to go. No more waiting days on a support ticket. And the same applies for every single change that you can imagine. It's now in the hands of the user, and they are empowered to do it when they feel ready. So with all that said, I think I've taken you on a little bit of a journey, and I see that it's not that easy to do all of this on your own. I hope that you've learned something today, and if ever you can apply it in your own environment, please do. My name is Peter Barta. I'm from NBIM, and you can find me outside to talk to me about the company or what I've done here today. Thank you so much.